Hello, everyone. Welcome to our case study. So, today we are from Group 7, Part B, and we will talk about platform design and construction issue. Now, this is our lesson outline. For this case study, we will talk about 8 important points. The first one is the background of case study, the issues, root causes of incidents, impact, analysis and discussion. The next one is the role of QS, lesson learned, and the last one is the recommendation or improvement strategies.
Now I will discuss on the background of this case study. This case study is about a deep water horizon that was a semi-submersible drilling rig owned by Transocean and operated by BP in the Macondo Prospect, Gulf of Mexico. During well completion operation, an explosion occurred due to uncontrolled hydrocarbon release, leading to a blowout fire and the largest marine oil spill in US history. Now, let's talk about the key issue behind the Deepwater Horizon disaster, which is design and construction issue. Design problem included inadequate well design, failure of the blowout preventer, insufficient safety redundancy, and poor risk assessment. Next, construction issue included defective cementing work, improper testing procedure, cost and schedule pressure affecting quality, and poor coordinating among contractors. So altogether, these failures allow hydrocarbon to escape, leading to the catastrophic blowout and oil spill.
Next, this slide presents the root causes that contributed to the Deepwater Horizon disaster in 2010. The causes can be grouped into technical, human, management, organizational, and external factors. From a technical perspective, the accident was linked to cement barrier failure and the incorrect interpretation of pressure test results. This issue preventing the well from being properly sealed, allowing hydrocarbons to flow into the wellbore. Next, human factor also play a significant role, which is poor decision making, inadequate communication among project personnel, and failure to follow established safety procedure contributed to the misjudgment of warning signs before the blowout occurred. The management factor also included insufficient supervision and monitoring, as well as pressure to reduce project delays and costs. These priorities may have influenced critical operational decisions. Then, organizational factors such as ineffective risk management, complex contractor interfaces between multiple parties, and lack of accountability further increases the risk. And lastly, the regulatory gaps and inadequate enforcement of industry standards represented important external factors. The combination of these factors ultimately led to the catastrophic blowout and explosion of the deep-water horizon offshore drilling platform. Moving on to this slide, which is highlight the major impacts and consequences of the Deepwater Horizon disaster on human life, the environment, economy, and the oil and gas industry. So, in terms of human impact, the explosion resulted in the death of 11 workers and injuries to several others. The tragedy also caused significant emotional and social effects on their families and communities. Next, environmentally, which is approximately 4.9 million barrels of oil were released into the Gulf of Mexico, making it one of the largest marine oil spills in history. The spill causes extensive damage to marine ecosystem, wildlife habitats, and coastal environment, with some effect lasting for many years. Then, the economically, the billions of dollars were spent on cleanup operation, compensation claims, legal settlement, and environmental restoration efforts. The industries such as fisheries, tourism, and local businesses also experience these significant losses. At the industry level, the disaster led to stricter offshore drilling regulations, increased safety requirements, higher operating costs, and reputational damage to the companies involved. Overall, the Deepwater Horizon incident demonstrates how failures in platform design, construction, and safety management can result in severe and far-reaching consequences.
For the part analysis and discussion, we are analyzing a critical incident that served as a stark reminder of what happens when cost reduction and schedule pressures are prioritized over human safety. When we look at the root causes, this accident wasn't just a stroke of a bad luck. It was the direct result of technical failures, human errors, and poor management practices. Under intense cost saving pressures, the organization's safety culture weakened, leading to a series of highly unsafe decisions. The consequences were devastating: a tragic loss of lives, severe environmental damage, and massive economic losses. While this disaster did prompt stricter regulations and improved safety measures afterward, it ultimately highlights a lesson we must never forget: the absolute necessity of effective risk management and strict safety compliance from day one. This brings us to a vital question: how do we prevent this from happening in our own projects? The answer lies heavily on the shoulders of the quantity surveyor. A QS isn't just a numbers cruncher. A quantity surveyor plays a crucial role in ensuring safety, quality, and value throughout the entire project lifecycle. They serve as a line of defense against the very pressures that caused the disaster we just discussed. Specifically, a QS protects the project by ensuring reasonable budgeting for safety systems and quality materials, making sure safety is never underfunded. Managing the procurement process to select only qualified contractors and reliable suppliers. Evaluating life cycle cost for safety equipment and systems, looking at long-term value rather than just the cheapest upfront price. Balancing cost management actively without ever compromising safety and construction quality. Driving risk management and robust contingency planning. And finally, monitoring strict compliance with contract specifications and regulation.
From the Deepwater Horizon case study, there are five important lessons that can be learned. First, safety must always be the highest priority. In this incident, operational decisions were influenced by time and cost pressure, which contribute to unsafe conditions. Second, multiple safety barriers should be independently verified. Critical systems such as cement barrier and blowout preventer fail simultaneously, showing that relying on a single layer of protection is insufficient. Third, effective communication among stakeholders is essential. Poor communication between the operator, contractor, and engineer lead to misunderstanding and poor decision making. Fourth, proper quality control and testing procedures are critical. Warning signs and abnormal test results were not adequately addressed, which increased the likelihood of failure. Finally, a strong safety culture reduces operational risk. Organizations must encourage accountability, compliance with safety procedures, and proactive risk management. Overall, the Deepwater Horizon demonstrates that strong safety management, effective communication, and rigorous verification process are essential to prevent accidents in projects.
For recommendations and improvement strategies, uh, to prevent similar incidents in the future, several improvement strategies can be implemented. First, organizations should strengthen their safety culture by prioritizing safety over cost and schedule pressures while encouraging workers to report potential hazards. Second, risk management practices must be improved. through comprehensive risk assessments and proper verification of well integrity before drilling operations begin. Third, equipment reliability should be enhanced by conducting regular maintenance and testing of critical safety equipment, such as the blowout preventer, as well as adopting real time monitoring systems. Finally, regulatory oversight should be strengthened through more frequent inspection and stricter enforcement of safety standards to ensure compliance across the industry. These measures can significantly reduce operational risk and improve safety performance in offshore oil and gas projects. Thank you.